Right, thanks everyone for coming. This is the next talk in the IT and operations track. This time we've got Sarah Christoph and Mustafa Gay, who are going to tell us IT Tales of Woe.
Cool. Thank you so much everyone for coming. And we're going to tell you some customer stories we had and their experiences with Kubernetes and Docker EE. Little background, my name is Sarah Christoph. I'm a cloud systems engineer at a company called CloudReach. You can view my blog, puponalaptop.com. And you might see some really cool stickers with my dog on it floating around the halls.
So hi everyone, my name is Mustafa Gay. So I'm a solution architect working at Docker for several months now. This is my first DockerCon, so I'm very excited to be here. So anyone here is at a DockerCon for the first time? Cool. So I feel less alone now.
So after months of planning, those container things are now running in prod. Maybe you're using Kubernetes, maybe you're using Docker EE, some type of orchestrator. But what you really want is to stop being woken up by PagerDuty at 2 a.m. with a "this is the alert" call. Because everything you set up is self-healing, right? So we're going to share with you some of the oddest, the most learnable moments we've gathered from our customers so that when you get that call, you'll have some good starting points. We'll cover an issue with infrastructure, one with an application, and one with networking. And hopefully you can effectively use this information that morning when you get that call. We'll start with a problem you may experience with your infrastructure.
So at a lower level, the infrastructure can be a silent killer. And as we are running container, it will be a serial killer, right? So this is what one of our customers learned the hard way. They were running Docker at scale with thousands of containers for more than 400 developers. And for months, they were trying to figure out what was going on inside the platform. That platform was actually installed on-premise on VMware, so pretty classic, right? And they were seeing their managers having a high CPU load. And the platform was slow globally, the deployments were taking forever, and some comments were hanging, and as you can see here, the containers were unstable, being rescheduled from time to time for no reason. And as you can see, the containers dropping while the CPU load was spiking. So of course, they were seeing some messages in the logs, but nothing was explained quite clearly what was going on. So for months, they were spammed by angry developers, receiving emails, instant messages, phone calls, and they were asking why their builds were failing, why the application was so slow or even unreachable. And they had to spend a lot of time trying to explain things they could not explain, they could not understand themselves. So at that time, the platform was pretty hard to manage as they were facing outages almost weekly. And all the ops team could do was to restart the platform whenever it was in a really bad shape. So the first assumption they had here was the resources. The platform was quite popular, and they were onboarding a lot of new team of developers daily. So they thought that maybe they have reached a threshold where they just needed to add more nodes and more resources to their nodes. So they did. They added more RAM, more CPU, everything. But unfortunately, that didn't help because days after that, they would face again some outages. So the next suspect they had was the build. They had dedicated a collections of nodes, specially dedicated for building images inside the platform. All right, that was working very, very well. But they thought that maybe building images is too much resource consuming. So they studied the case and decided to move the build part outside of that platform in a dedicated one, in a separate one. But here again, that helped a little bit because the platform was released for like 2 weeks or so, but then the issues started to hit again. So at that moment, they started to be a little bit desperate as they were running out of tracks. So some fingers started to point at Docker itself. So maybe the product has some issues we're not aware of and is leading to these issues. So these outages, sorry. So they decided to update everything they could, including the OS, the Docker UCP, the DTR, the engine itself. And from then, they reached out to Docker support for some help, providing them all kinds of logs, everything they could, traces, everything. Having weekly screens to try to live debug and find things. But unfortunately, the root cause was still to be found. But the Docker support had one question that was always coming back from them. And the question was, did you have infrastructure or networking issues by the time of the outages? So unfortunately, the ops team couldn't really tell because the cluster they were using was used by all the organization in the company. So it was managed by another team. So at some point, they figure out the way to have access to the vSphere client, which is the UI you use to manage your virtual machines and have access to metrics and logs. And what they discovered there was just crazy. Their underlying clusters were overloaded. So what is a cluster? A cluster is a group of hosts tightly coupled to act as one big computer, right? And VMware ESX cluster is the same. It's a group of hosts used to achieve high availability and virtual machine load balancing. And that virtual machine load balancing is called DRS, Distributed Resource Scheduler. So this is an interesting feature from VMware and how it works. Whenever a physical host is overutilized by a virtual guest, then that virtual guest or another one next to it is moved to a less loaded one. Okay, this happens seamlessly. So that mechanism of moving the VMs from one ESX host to another is called vMotion. All right, so this is very good because your virtual machine is moved without you needing to turn it off. So it happens in the blink of an eye, and your virtual machine is gone. So by all the time you have that overutilization in your cluster, you may have what is called CPU ready. Okay, so there you have it, the next two suspects, the vMotion and the CPU ready. So let's break down a little bit what is CPU ready, because the term here is a little bit misleading. So CPU ready is a metric used to see the amount of time where your virtual machine was ready but couldn't get scheduled to run on the physical CPU. Okay, that value depends on the number of virtual machine you have on your host and their CPU loads. Okay, so there's no way a virtual machine can have access to all the resources of the physical host, but VMware knowledge bases recommend to maintain that value under 5%. Okay, 5%. So in our case, that value was often flying over that. As you can see here, we were having more than 10,000 millisecond max and an average of 3,007 milliseconds within an hour. Okay, so system-wise, they were seeing a load average of around 16. Okay, so a load average basically means that when you have one CPU and you have a load average of 1, roughly, that means that your system is overloaded. Okay, you have no more headroom for running more processes. So here, they have 12 CPUs and they were seeing a load average of 16. So clearly, their system was overloaded. Okay, so Sarah, why don't you break down how to calculate the CPU ready with the figures we saw right before?
Yeah, so it's important to note that these performance graphs are based off 20-second data points. So to do some math, which wasn't ever my strongest subject in high school, we'll take that screenshot upper percentage value and take what is reported, that 3,700 milliseconds, and we divide it by 20 seconds, 20,000 milliseconds. To arrive at the CPU ready value as a percentage in this graph would be about 18.5%, which is almost 4 times above the 5% guideline.
Okay, so here you can see that it was 4 times the guidelines, but this wasn't in times of crisis. This was most of the time. Okay, so when they were having outages, it was looking like this. So yeah, that's a lot. At these customers, they took the part of oversubscribing their infrastructure because they had a mixed workload, right? They had some VM running really low workload, like an Apache here or a Tomcat there, nothing crazy. And besides that, they would have some monster VM running huge workload. And that's the thing, you never know who your neighbor is actually. And how come you never know who your neighbors are? Okay, that was because vMotion was happening way too often. Okay, and Docker recommends to avoid vMotion because when it's too slow, the reaction of the swarm is to kick that node outside of the gossip. Okay, so this happens within milliseconds, but that's enough. And since the whole cluster was overloaded, most of the vMotion were just too slow. So imagine you have half of your nodes struggling for resources to run and moving up to 25 times a day. You guessed it. That was the reason of the churn in the platform. Okay, whenever a node was too slow, it was kicked outside of the cluster of the swarm, and the containers on it will eventually be rescheduled. So when you have this issue on your managers, on your swarm managers, it's even worse because the managers are not able to fulfill their roles. Okay, and that was causing a cascade of issues like node leaving the cluster, the swarm, and containers being rescheduled all the time. And that was causing the overall load to spike. So slow motion plus CPU ready was causing this snowball effect in the cluster and was leading all the time to outages. So once the customer figured out how all this was happening, they took action and start moving their VM from overloaded clusters to other less loaded cluster. And they started to apply as much as they could pet versus cattle. Okay, whenever a node was struggling for resource, they would drain it and replace it by a new one. Okay, so that was made possible thanks to their level of automation and by monitoring some signs of weakness they will see.
So how many of you know what pet versus cattle is? Do a hand. All right, so most of you, that's good. So just for anyone who doesn't know, because I'm always told to explain everything. So basically you should treat well, at least in some of the companies I've seen, they treat their infrastructure like pets, which means when it's sick, we take care of it, we take it to the vet, maybe we install special packages on of it, things like that. In my case, we give them very nice collars and treats. And then, so we should apply the mindset that our infrastructure should be treated like cattle, which is when it's sick, you take it to the farm, as my parents say. So it's a little brutal one. So I always say it's like plates versus cups. Wash your cups, put them away. Plates, use paper plates, throw them away. You want your infrastructure to be something you can kill whenever it's acting up and it just starts up new. That way you don't have to spend hours troubleshooting it. That way you achieve a really good level of automation and you're not wasting a lot of ops time.
All right. So in the lessons learned, the first thing is don't oversubscribe your infrastructure, okay? Docker is here to help you rationalize your resources. So doing optimization over optimization is pointless, okay? CPU ready, DRS, vMotion. So these mechanisms are great for maintenance purpose and high availability. But when you use it in an excessive way, it will lead to unexpected behavior, right? So don't get me wrong here. VMware is one of the Docker certified infrastructure. That means that it works flawlessly on it, and we have numbers of customers that are happy with it. This case only shows that whatever product you're using, you just have to read the manual, because when you're using it wrong, you will only have some issues. That's it. Yep, for this one.
So next up, we'll talk about an application that went out of control without being set proper limits. Just like you gotta set boundaries with your kid, gotta do the same thing with your application, or else it will end up throwing a tantrum and breaking everything.
All right, so here's the story of another customer who had a specific use case where they needed to deploy a stack of 40 containers with a lot of Java in it. So it's not that specific, it looks like a Netflix stack. But yeah, don't try this at work, of course. So whenever they try to deploy the stack, the system will become unresponsive or eventually collapse. So it was really frustrating. So the first assumption they had, once again, was that their nodes were not powerful enough to run the stack. And they were quite right, because the first thing they did was add more resources, and eventually they were able to deploy the stack. But when it was running, it was first taking just a huge amount of time to deploy, and when it was running, they would see some containers being killed randomly. So the second suspect they had was Java itself, all right? So they spent quite an amount of time trying to optimize the code, tweak little things here and then. But unfortunately, here again, they only lose more time because it didn't really help. And the deadline was approaching, and they needed to go live quickly, so they started to be more stressed. So at that point, they reached out to Docker for some help. And it wasn't easy to troubleshoot at first, but the first thing we noticed was that whenever they were deploying the stack, they were seeing a load average of 600 or so. So like I explained earlier, when you have one CPU, you have one of load average, you're running at full, and here they had 32 CPU. So I'll let you do the math. So in a situation like this, you can have two things can happen. Either you're running out of resources, you're running out of CPU, what was most likely what was happening at that customer, or worse, you will hit out of memory. Okay, so by default, a container is not limited in the amount of memory it can use. Okay, amount of resource it can use actually. So there's two things here. You have the CPU. The CPU is a compressible resource, while memory is incompressible. Okay, that means that when your containers request more resources than what is available, in terms of CPU, it will only have to wait for CPU time to resume its task, and eventually your container, your application, or your system might be slow, right? But your container won't be killed. But when it comes to memory, when your system is running out of memory, it will issue a function called OOME, or out of memory exception. All right? So that is bad because when it happens, any process on your system can be killed, including the Docker daemon. All right? So Docker tried to mitigate the issue by setting the out of memory priority so that the Docker daemon is less likely to be killed than other processes on your system. But anyway, you don't want to have that on your system. So for this customer, we recommend a few things to get out of this situation. All right. So, and one of those was to set resource limitation and reservation. All right. And by tweaking the Java version they were using. So Sarah, can you explain one of the issues you can have when you're running Java on containers?
Right. So this is an issue close and near and dear to my heart. My coworkers will tell you I'm very loud about it. But Java uses the JVM. Because of that, when you're running it inside containers, it still needs to use the JVM. Until recently, the JVM didn't really abide by the limitations you put in a container. So what you would have to do is set the resource limitations on the JVM and then add a buffer in the container resources so that if the JVM decided for some reason it wanted to overextend those boundaries, it would not hit an OOM exception and then crash the container. Had this happen with a couple of customers in deploying Java apps, and it was very fun to troubleshoot. So you just have to be sure when you set those resource limitations that Java is also abiding to those.
All right, so as soon as the customer applied those recommendations, they saw a huge improvement in their workload. And the way to do it is quite simple. You just had to add these entries, these resource entries, in your Docker Compose or your Kube manifest to look like this. So in this example, if you have 2 CPUs, you will be guaranteed to have at most half of those CPU to run and at least 25% to start with. So when it comes to memory, you have to be a little more mindful, okay? If, for instance, you have an environment with a low SLA, you can go the way in the left. You set your reservation below your limitation, right? And eventually, the containers will grow, and at some point, they can oversubscribe your memory, and you will start having some containers being killed. But if you're running an environment with a high SLA, like production, for instance, you may want to go with the implementation in the left. Right, on the left, yeah. So this way, you set reservation equal limitation, and then you will never oversubscribe your memory. And in addition to that, you can add, you can deploy a global service that does nothing but reserve a low amount of memory just for the system. So this is just security, all right? So the key, the lessons learned here are perform tests to understand the memory requirement of your application before placing it into production, right? You don't want to discover memory issues when you're in production, when it's too late.
You should always set limitations on your application. Like I said, just like you need to set boundaries with your kids, set it with your applications. I don't have kids, so I don't actually know how you do that with the kids thing, but containerize and contain your application. That way you don't have problems in prod.
And use service level constraint to add node label and add node label to ensure that your application only runs on nodes and hosts with enough memory. So you don't want any collateral damages. You have to remember that you're running containers in a shared environment with other containers, so you don't want to ruin others' jobs.
The last case is a headache we encountered after we pushed our application to prod. At CloudReach, we're a consulting company, so we go to other companies and help them take their projects and make them real. Basically take their dreams and make it reality. Just a nice way to say it. So basically, we were using the Docker default bridge network and the default DTR overlay network. They were using Docker Enterprise. We developed a bunch of stuff in AWS, and we were about to migrate it over to their local data center, and things seemed to be working fine. Or smashing, is what I was supposed to say. Hours before we hit prod, we started getting some really nasty errors. Started randomly losing contact with nodes at times. They'd go in and out of service. Health checks were passing, then they would fail again. Cycle would repeat. They were seeing a lot of 502 bad gateway errors as well. So we started running ping tests from our Bastion host to a set of IPs that made up all of the nodes. And we would get varying results. About 60 to 70% would report back healthy, and then 30 to 40 would time out. And this would go on and it would change, right? We figured it was a problem with the availability zones because we were deployed in 3 different availability zones, but that wasn't it. So we did a route table inspection, and that led us to find the conflicting route tables between the on-prem data center and what we set for the Docker overlay networks. So basically what happened is everyone kept fighting for the same kind of different networks and ranges. So in the end, we had to redo the whole thing and work with their networking team to make sure that everyone was on the same page when we redeployed this. That way, we stopped overlapping with everything. And so while Docker provides some great defaults around networking, it's very important to validate the internal and external network design. On top of that, talk with stakeholders, talk with your network engineers, talk with everyone before you deploy stuff into prod. It seems pretty baseline, but you'll be amazed at the amount of times there's a hidden team somewhere in a back corner that knows a lot more about their prod environment than you do. So just make sure that everything's green before you push it on to your on-prem. All right, and so in summary, make sure that you're trying to follow the pets versus cattle paradigm as closely as possible. The more pets you have, the more dangerous it can be when something breaks.
Yeah, and also we used to build our systems for availability. All right, we used to rely on the fact that the system will never break. But now with by having everything redundant, and now with the modern cloud architecture, we need to build for failure. All right, assuming that failure can happen and will happen, like Murphy's Law, right?
And you also need to make sure you set boundaries with your applications. Setting resource limitations allows you to control and monitor your application more efficiently. Lastly, sometimes the defaults won't work for you, and honestly, they shouldn't. So double check with your network engineers, talk with stakeholders, and make sure everyone knows, hey, when I'm deploying something, let's make sure it's working correctly, and it won't break other things. All this art was done by this amazing artist. Her name's Mai. She's great. If you're gonna do a talk and you don't wanna spend like forever building it, go talk to her, she's great. And it's a broken image. Thank you so much. And you can find me on Twitter, @Christoph25. There's an anonymous feedback and question form. If not, we can do Q&A too. And I have stickers of my dog if you want them.
And don't forget to rate the talk if you can, the application. Thank you guys.
Great, thanks. Do we have any questions for Sarah and Mustafa?
That's the first.
Hi. In the first case, you meant, I think, if I recall, the solution was done on the host side, right, and the infrastructure side. But if I'm not in control, or if is it also valid to maybe do configuration on Docker to not have this gossip timeout, or have a higher timeout, or is that a bad idea?
Yeah, you can hire the time where the Raft is doing his tick to check the nodes, right? So this is just high availability, so it depends on your SLAs. You can have those set higher, but if you really have an issue, you may have bigger issue. So you just have to be careful when you're setting those.
And also the Raft health checks, or heartbeats they're called, they randomize in timeout from 2 milliseconds to 200 milliseconds. So a lot of the times, based off those randomized timers, you'll see a node drop out, but really it's just healthy. So be careful resetting those limitations. That's the Raft default, and Raft is fun, read up on it.
Advice, any other questions?
You talk about the Google Sheet.
Yeah. All right, well, if you guys get any more questions, just find me on Twitter and you can submit it on Google Form. We'll both see it, and have a sick day.
Yeah, I also have a hallway track if you want to discuss something.
Oh, yeah.
Don't hesitate.
What time is your hallway track?
Whatever, just try to schedule something and I'll make it out.
Okay, thanks again, Sarah and Mustafa.